Usually, the volume of the music has to usually do with how tired I am. It's like, if I'm cranking it up pretty loud, there's something about me is probably tired. So, and when it shuts off on its own, you know it's all good. All right, so today we're going to talk about a test for independence. Okay, so let's just get right after it. You know, let's just do that. I hope you're having a beautiful day. It's true. You deserve it. You deserve at least that, right? Okay, so here's the test. Well, there's a couple, but let's talk. What we're going to do, anytime we ask, are two events independent, what we're asking is, does the existence of one influence the probability of the other one happening? Okay? So if we have two events, A and B, what we're going to ask ourselves is this. Does the probability of event A equal the probability of event A given that B has occurred? If this is true, then the events are independent. And I'll say that again. If the probability of A is exactly the same as the probability of A given that we know B occurred, then B must not be influencing A. They must be independent of each other. So let's look here. This says, are the events first class and survived independent? Well, let's look. Let's do that. Here's our data table of the passengers of the Titanic. So what we'll do is we're going to ask ourselves two things. We're going to say, what is the probability of first class? Okay, so let's do probability of first class. What a perfect video. I hope you can hear the chainsaw going. It's all good. It's all good. I think when I got better at videos is when I stopped trying to be perfect. When I just said, I don't even care anymore. I was going to do the best I can. And then let's just cross our fingers and hope it works out. So the probability of first class, you can see we've got 324 first class passengers. Oh, my blue marker coming to an end. I hope the next one I pick up works perfectly. We'll see. So what do we got here? 324 divided by 1,317 gives me 24.6%. Okay. Well, I'd actually, we could do this, but I don't think it's as interesting. I want to do survived. So you could do first class there, but I think I'm going to switch and do survived. Not a big change. Not a big change, but that's 500. It's a more interesting question, and I'll show you. I'll talk about why it's more interesting, but it's more interesting to do this way. Okay, so 1,317. So we get 37.9. So if we're going to round, we're going to go 0.38. Okay, so the probability of surviving on the Titanic, 38%. If you just picked a random passenger, there's a 38% chance. Okay? But the question for us is, what happens? What's the probability of surviving given that first class has occurred? That's the question for us. Does the existence of first class actually increase or decrease your chance for survival? Or someone's chance for survival? I don't know. I say we look. I say we try it. So let's do this. So let's go. What's the probability of survived given, okay, conditional probability, given that first class has occurred? So let's do purple for first class. All right. I love it. I love it. I love it. Okay. Well, let's see. So remember, with conditional probability, this has occurred. This says, what's the probability of survive given that first class has happened? So when you randomly select somebody, you ain't going to select no one from second class because first class has occurred. And so the denominator is actually now 324. All the people from first class. We know we've selected somebody from first class. Now, what's the probability they survived? Well, we had 201 people who survived and was on first class. Let's just keep going. I gotta get I'd imagine this chainsaw in the background. I can probably hear it better than you. I think maybe the mic on the camera buffers it out a little bit, but for me, I can hear it pretty well. Oh my gosh. 62%. Okay. So, this means that the events first class and survived are not independent because the event first class has increased the probability of the survived from 0.38 to 0.62, or from 38 to 62%. Therefore, they are not independent. I'll write it out for you. Okay, so I recommend writing a sentence. The events first class and survived are not independent because first class increases the probability of surviving from 0.38 to 0.62. Or, simply put, this is not true. The probability of survived does not equal the probability of survived given that it's first class. You know, there is actually one other way you can think about this. Hey, look at this. This is quick, but I have to do it because remember the probability of A and B has to equal the probability of A times the probability of B. If A and B are independent, that has to be true. So you could check. You could just say, okay, well, what's the probability of surviving and being first class? That's the 201 out of 1,317. And then you just ask yourself, is it actually equal to the probability of first class, which is 324 over, times the probability of surviving? You just simply ask yourself, is that true? Because if it is true, then they must be independent. And then you'll see that it's not true. It's not true because in this case they're not independent. They are very much dependent. It appears that there is an association where first class increases your probability of survival. All right. Well, be silly, be honest, and always trust your cape. I'm out.